Hello, how is everyone?
Hello.
Hello, it looks like I'm only alone, everyone.
Yeah, there's quite a few people on.
No, really.
Yeah, we're still a few minutes early, so we'll give everyone another couple of minutes to join before we get kicked and start kicking off.
So how hot is it in Vancouver today?
I haven't been outside, so I don't know.
You haven't been outside.
Hot.
Hot.
Yeah.
It's pretty hot here. It's like 31 degrees around Burnaby area. So I'm guessing
I
should be
live
around
in
this.
Burnaby, and like the other day at my house, it was 35 degrees, and I live in an old house, so there's no air conditioning. And yeah, about 2 weeks every summer, I'm like, I should really get air conditioning. And then the 2 weeks go by, and it's like, I don't really need air conditioning.
Yeah, it is really those couple of weeks that are really hot and then things start to cool down. Well, more or less.
They become more bearable, right? Like
Yeah.
there's that boundary between like a fan will do, and then you want air conditioning, right? And so the fan buys you about 5 degrees.
Yeah. I mean, the fan doesn't really cool things down a lot, but just like helps you get by.
Yeah.
Okay.
Give everyone another minute before we start, because I think I saw a couple of people join and then sign off because we hadn't started quite yet, so we give them another minute. Does anyone have any plans for the long weekend?
Not really. I'm going camping the following weekend, so.
I'm going camping this weekend, so definitely no air conditioning involved.
Yeah. It's okay. The tent has natural airflow.
This is true. We'll have to just really well ventilate and.
Hopefully you're camping somewhere near water and it's better.
We are. We're going to be out at Sasquatch Provincial Park right by Harrison Hot Springs. There's a couple of lakes nearby.
Yeah. So there you go. You just go for a swim in the lake.
And we're saying there's no showers. We'll be like lake baths. So
yeah,
good. All right, so it is 6 o'clock on the dot, so that we can get started. Firstly, thank you and welcome everyone for joining VanQ for our July meetup. And thank you to Michael, who's been so great and agreed to speak at our meetup today. Let's pass things over to my colleague Shobit, who'll kind of just run you through a little bit about VanQ and a couple of housekeeping items as well. I will ask everyone to just keep themselves on mute, and then he'll kind of go over how we'll ask questions and stuff like that a little bit later on. All right, you can take it, Shobit.
Thanks, Jocelyn. Hi, everyone. I hope all of you are doing well. I'm Shobit, and I work at Optimus Information, and we are the sponsor for VanQ. This might be the first time for some of you, so we organize this meetup every month, and we get speakers to present on different topics. So for today, I'll just quickly touch up on some of the housekeeping items that we have. And this may be the first webinar for VanQ webinar for many of you. And I'll also touch upon a little bit about what we do. So Optimus is a tech solutions company, and we help other organizations in their digital transformation. And we essentially help them migrate to the cloud. And we are a Microsoft Gold certified partner with 7 gold competencies. We offer a wide array of services like cloud management, DevOps, application management, data and AI. And you can check more on that on our website. Also, if anyone is looking to apply to any positions within the tech industry, then you can check out our hiring page on our website. So we have two centers of operation. One is in Vancouver, Canada, which is the headquarters, head office, and the other one is in India, New Delhi, India. And so let me just go over some of the housekeeping details for our webinar today. So I would request all of you to keep your mic on mute so that it's easier for Michael to present. And also, if you have any quick questions, feel free to put them in the chat, and we can unmute you so you can ask your question to Michael. And if it's a longer one, we ask you to reserve it until the end. It would be nice to have your video turned on so we can have more of an interactive session, and at least this would be the next best thing in this pandemic, because we can't exactly meet. So, video is what we'll have to do with. So without further ado, I would like to now hand it over to Michael, who's going to be presenting today. And yeah.
All right. Thank you very much, Shobit. Appreciate the introduction. I'm going to share my screen now. So hopefully everybody can now see my screen. Somebody give me a thumbs up. There we go. All right. So my name is Michael Argast. I'm the CEO and founder of Cobalt Security Inc. We're a security services company that focuses on tech companies, small businesses. And today I'm going to be talking about strategies for evaluating and ensuring your code security and resiliency. So a little bit about myself. I've been in information security for over 20 years, which I like to say means that I've forgotten more than I know today, and most of the things that I learned early in my career are no longer true or accurate. And security is a business that's changing all the time. And a classic example is the move to the cloud, and that has a huge number of implications in security, as well as code and how you keep code secure. My career spans pretty much every different kind of security function, so everything from IT operations, sysadministration, development, sales, leadership, consulting roles, and I've had leadership and individual contributor roles at Sophos, TELUS, and other organizations. I participate a lot in various security communities and events here at the ISACA chapter, so BC Aware, if any of you have ever been to that event. And I'm a member of the Provincial Security Advisory Council that helps advise the province of British Columbia on security best practices and trends and changes of the industry. And always looking to meet new people and connect with them and spread the good word on security. So please feel free to reach out and connect to me on LinkedIn and Twitter. So a little bit of a background and agenda on what we're going to go over today. I'm going to start with an example of a compromise. So just kind of a story. Then we're going to talk about different methods of evaluating code security and how to choose and prioritize where you might want to apply your efforts. There's a lot of different buzzwords and phrases and approaches, and I'm really trying to give you a foundation so you can understand when and how to apply different technologies, approaches, services, so that you can make sure that your code is secure. And then kind of a discussion and roundtable, so an opening up for any further questions. So quick story of a breach. There's pretty much every single day, if you pay attention, you'll hear about another significant security breach. Last week was Twitter, right? And I imagine a number of you heard that, Elon Musk and Bill Gates and everybody else's accounts were compromised in order to get Bitcoins and stuff like that. Here's an example of a breach, Canva. If any of you do any graphics design, you might be familiar with Canva. It's a very popular tool. I hadn't even heard of it 6 months ago, and 137 million user accounts. So obviously it's a pretty popular service. And so they had a breach a little bit over a year ago that impacted the usernames, passwords, email addresses of a huge bulk of their users. One of the things that's really interesting from this breach that I think is kind of a neat thing to learn is that they had salted and hashed their passwords with a tool called bcrypt. And one of the things that we see often is people who code and set up user databases. People will do all sorts of different things. They will just store it in a flat file. They'll encrypt it with ROT13. They'll do very basic kind of storage of things. Bcrypt is actually a really, really good standard, and it's very strong. Salting and hashing is a combination of adding a small piece of text to your password, and hashing is rotating it through a hashing algorithm multiple times. That makes it very, very difficult for the password to be reversed and reverse engineered. However, as you can see further down this particular write-up, according to a later post by Canva, a list of over 4 million accounts that were stolen were actually later decrypted. And I can talk a little bit about how that was done. Another thing that's really interesting is often people think about the account, they go in and they change their password, and that's useful, but they sometimes forget to kill existing tokens or sessions of people who are connected to that service. And so in this particular case, the attackers claimed to have gained OAuth login tokens, which meant that a ongoing and persistent session could be maintained by the attacker even through a password rotation. So those needed to be killed off before the service was properly locked down. So this is an interesting example of a breach. And the reason I give it for context is, when you're thinking about your code security, you got to think about like what happens and how it happens, the contributing factors, how is my code secure, and how do I make sure that this sort of thing doesn't happen to my organization? So next, I'm going to talk a little bit about kind of when and how you want to apply code security. And so some of you may have heard of this concept of pushing left in security. And the idea behind pushing left is the later in the development cycle I discover a bug or a code or something that a flaw or something that I need to change, the more expensive it is. So for example, in the case of the Canva breach, the flaws and compromises that allowed their systems to be hacked, they were discovered post-breach. And so that ended up being a very significant expense to them because they had to experience the breach, deal with remediation, clean up media, all this kind of stuff, right? If I can deal with those bugs and vulnerabilities during the development phase, then again, it's less expensive, right? So that's, before it gets into the public and is potentially compromised. Even better, if I go all the way back and look at how I'm defining the requirements for my application to reduce the chance of that type of attack occurring, or the collection of data that I don't need, or any of a number of different approaches, I can dramatically cut my cost. And from an order of magnitude perspective, what might cost me $1 in terms of requirements can cost me $10,000 in terms of a vulnerability or an attack that is experienced in release. So, we're always making some trade-offs though, because as much as I want to do the right things from a design and requirements perspective up front, very often I'm rushing to get to market, I'm developing new features, and I don't always have the option to do things perfectly. So there's a balance to be struck in all of this. The other thing that's kind of important to understand is that, after I've released the code, it lives in production for quite some time. Even in an agile environment, like a particular piece or snippet of code can live in the wild until it's replaced. And so, it's not just kind of detecting the vulnerabilities and issues prior to release, but also detecting the activities that could compromise that vulnerability post-release. And so a classic example of this is, the longer it takes me to detect an attack or incident as it is occurring, the more expensive it typically is for that organization. Because if I can cut off an attacker early, if I can see their early, kind of door knocks and attempts to break into my system, then I can dramatically reduce the cost. But if I detect it after they've stolen all the data, they've leaked it on the dark web, I haven't had a chance to respond to it in the media, that can be very, very expensive. And so, the more significant breaches that even small mid-sized businesses experience have very significant average costs in the order of millions of dollars. Another thing that's really important is over half of breaches are actually detected now by a third party. So that's like the FBI or Microsoft or somebody else understanding that your system's been compromised rather than the company itself. So now I want to start to put a bit of understanding around how you might apply different security approaches to, identifying code in terms of vulnerability and in terms of resolving those vulnerabilities where they might occur. So I'm going to start at the left and kind of work my way right. So security architecture and design is about applying security best practices and principles to, reduce risk in my application. So a good example of this in the Canva breach story that we just heard is that although Canva had 137 million users, only about 70 million of those user accounts were compromised. And one of the reasons behind that was they actually didn't have user account information for the other half of their users. They had leveraged the concept of social logins in order to not have to create user accounts with email addresses, passwords, and those sorts of things. And so as a result, they had dramatically reduced the size of a breach should it occur because of using this other technology. So that was a security architecture and design choice. In the case of usernames and passwords, again, very often I will see organizations say, I don't want to get into this at all, and they will use a third-party service for user management, which can, offset their risk and reduce the risk of them implementing something poorly. Then when we start getting into design, code, and testing, we get into an area of library and resource management. And so most of you who are developers will understand that actually today a lot of development isn't writing tens of thousands of lines of code. A lot of development today is assembling libraries and components into the building blocks that fundamentally then get glued together by my small amount of application code, right? So I might use a library that does, back-end database interfaces instead of writing that myself, another library that does visualizations, another library that does all these different things. One of the challenges with ingesting all these libraries into my application stack, however, is that libraries themselves can have vulnerabilities. And so I have to understand that and manage that vulnerability as well. So classically, OpenSSL, which is a very popular library that's used for SSL encryption between two endpoints, is very, very popular. A number of years ago, it had significant vulnerabilities that resulted in anything that ran OpenSSL to have a vulnerability for a period of time. That wasn't, an individual company with an individual piece of code. That was a library that affected hundreds of thousands, if not millions of organizations worldwide. So library management is important. And there's a number of tools and resources that you can use to help reduce the risk of taking bad libraries into your code base. And so if you're on GitHub, they have reputation systems that enable you to determine whether or not a code base is widely used, whether it has known historical vulnerabilities, and that helps you reduce the risk of taking on a project or taking on some code that is likely to cause downstream problems for you. Next, I'd like to get into SAST and DAST. So SAST and DAST are static application security testing and dynamic application security testing. And fundamentally what they are is they're assessing your code prior to it running. SAST looks at it purely from a non-running static analysis perspective. And so it's basically you're looking at the bytecode, looking at uncompiled code, and looking for vulnerabilities, common flaws, this kind of stuff. And these are tools that I can implement into my CI/CD pipeline so that as we're developing new code and checking it in, it's automatically assessed to determine whether or not it has vulnerability. Dynamic testing does the same thing, but it does a build of the code and tests the code once it's been built to see if it's got common vulnerabilities like, vulnerabilities to SQL injection attacks, cross-site scripting, input validation errors, this kind of stuff that can only be seen once the code is actually running. And so SAST and DAST tools are great ways to discover bugs and vulnerabilities that are part of your development process prior to them being pushed into production. And so, we generally recommend anybody who's managing a significant code base and has a number of developers to have SAST and DAST built into their pipeline so that you can identify bugs and resolve them during your development process rather than post-development. Another thing that's very much less common these days is actual code audits that are done by third parties where they go through a combination of SAS/DAST tools as well as manual audits to go through and review architecture, design choices, all these sorts of things within your code to see where there are possible vulnerabilities. That takes us into vulnerability scanners. And vulnerability scanners are tools that typically are used to scan your infrastructure. And this infrastructure could be your operating systems, your firewalls, your networking gear, but it also could include your cloud infrastructure. So it could include your Azure environment. It could include your microservices, your APIs. It can include Lambda services if you're on AWS. And so vulnerability scanners can basically assess a wide range of your exposed infrastructure to determine whether or not it has old libraries or non-vulnerable versions or other things that could be potentially picked up on a regular basis. Many organizations will integrate vulnerability scanners as part of an organization-wide assessment, and it helps really keep your infrastructure secure as well as the code that runs on your application side. Pause here. Any questions so far from the audience? I can't really see them, so I need to get Shobit or somebody else to tell me if there are. All right, I'm moving too fast, so I'm going to try to slow down even more. So that takes us next into BlackBox, GrayBox, and WhiteBox testing. And so very commonly when you are providing code that is being sold to third parties, so say you're a SaaS company and you want to go sell a deal to a Google or a Starbucks or somebody else, they will require that you get a third-party vulnerability penetration test assessment done of your application, right? And there's a lot of different terms that are thrown around, and I wanted to take a moment to explain the difference between these different terms. And so, very basic penetration test is a black box test. And so what this does is it simulates an attacker who has no inside knowledge at all of your organization, and all they can do is basically see the externally exposed interfaces and services, your login page, that kind of stuff. And a black box test is a test where you hire somebody to come in and do a pen test and pretend to be that external party, and they can only see what that external party would see and try to break in that way, right? And so very often they might find some very lightweight vulnerabilities like old encryption libraries or insecure versions of Apache or you name it, but they're not necessarily going to get to the meat of your application. So there's a bunch of things that you might need to patch or update in a black box test, but it's typically not going to require a significant rework of your code base. Next, we get into gray box testing. So gray box testing is like a step beyond black. And the idea is, we take the attacker from an external interface into an authenticated interface, right? And so classically, I've got my SaaS application and it's got the login page, and anybody can sign up for that service online, get a free trial account, or maybe pay $10 a month and get into the system. And so an attacker isn't going to stop at the front door. They're going to pay the $10 a month. You can get into the system. Once they're past the login page, then they have access to all these other interfaces, right? The rest of your application, right? So then they can try to do things like, response string substitution. They can try to see if they can manipulate any of the interactions between the client and the server to try to extract data that they shouldn't have access to. And so gray box testing is really the idea of taking that external view still, but giving them further access into your application like a real world user would have, or even sometimes an administrator, and see if they can get access to information or systems that they shouldn't be able to get access to. So that takes us next to white box testing. And as you can imagine, as I move from black to gray to white, the simpler test is less expensive, and the white box testing is the more thorough, complex testing, and it's the most expensive. It takes more time. And so in the example of a white box test, what I'm doing is I'm acting as a knowledgeable insider, right? So think of this as one of your developers has gone rogue, right? And so now I have access to your entire code base, your architecture diagrams, all this kind of stuff. And I'm going to try to see, where there's flaws and where I can compromise things based on this knowledge. So I might take your code and go, through some of the SAS and DSS testing on my own. I find a vulnerability that I wouldn't have been able to see from the outside world, but now that I have your code, I can see it, and I can act as a much more sophisticated attacker to come in and compromise your system, right? So if you think about a black box test, that might take, 2 to 3 days worth of effort, cost less than $10,000. And a white box test might take 2 to 3 weeks plus worth of effort and cost, $20,000, $30,000, right? So that gives you a sense of like, what you might be doing. And again, it was your customer or a desire by your organization to be more secure that drives this testing. And so you're going to want to apply the type of testing based on the sensitivity data that you hold, how often you do testing, how good your code security practices are, this kind of stuff, to determine where you want to enter in terms of the type of testing. So those are kind of 3 kind of testing methodologies that are really common. And what we run into is pretty much every organization, when they sell their code to third parties through an application or through some other means, has to do one of those tests, typically on an annual basis, to satisfy their customers. Then we get into bug bounties and what I call bug bounties. So bug bounties are, there's a variety of services. So instead of hiring somebody to do a test, I put a bounty out there and say, if you find a vulnerability in my application, I will pay you money. And there's services, BugCrowd and others, where people who are kind of amateur and professional testers can sign up, and then they get access to all these bug bounties, and then they go and try to break into people's applications. And if they find something valuable, then they get paid a reward, right? And these bug bounties can be, you know, a few hundred to a few $1,000s for something relatively minor, to like Apple and Google and Microsoft can pay bug bounties of hundreds of thousands of dollars if you find a critical vulnerability in iOS, for example, right? So this is a really big and growing industry for the penetration testing market, where people are, you know, basically being paid, and they don't get paid anything unless they find something, by organizations. One of the things that I always encourage companies to think about before they start embarking on bug bounties is you want to do the basics before you start paying out for people finding bugs. Because if you haven't patched your systems, if you haven't done some good white box testing and some other things before you offer bug bounties, you're going to be paying out a lot of money as people find relatively cheap and easy stuff with automated scanners and other stuff that could have been easily dealt with beforehand. And then something that we're starting to see rise up more and more frequently is something I call bug bounties, which is you know, typically researchers that are trying to find an easy way to make money, and they do like automated scans of the internet, and then they find a vulnerability, and they write to the website hosts of that vulnerability, or the application developers of that vulnerability, and they say, I found a cross-site scripting vulnerability in your application. Here's the details, please pay me $500. And they're kind of begging for money for finding a vulnerability from organizations that don't have like a public bug bounty program. So I'm seeing this more and more commonly amongst organizations, that they're receiving these kind of inbound bug bounties from people who are just finding kind of low value, not very sophisticated attacks, asking for money for like basically scanning the internet and finding these things. Next, I'd like to go into this little box that you see on the bottom, which I call secret trawling. And so one of the biggest challenges in code development is, like all humans, developers can often be lazy, and they're not necessarily going to do the right things as it relates to making sure that the secrets needed to allow inter-application communication are properly stored and accessed. So a classic example of this is, say, for example, I have two systems that are communicating via an API. And normally I might, you know, go through an authentication service in order to like get a token that allows me to access that API and, you know, communicate private information. But if I'm lazy, instead of like going to the token service to get that, you know, access, I might just hard code my secret, my password inside my code. And so that when my application wants to go and request it, I can, you know, just do that instead of having to like go through a broker. And so the problem with that is like everything gets out eventually, you know, my code gets out, somebody leaks it on the internet, and then I've got a compromise because that password is out there in my code base in an exposed fashion. And so there's services, we offer one where we can go through your GitHub code base, for example, look for any of these examples of hard-coded passwords or secrets inside your code, alert your developers so they can do the right security practices and remove those secrets. And often it's like, you know, one member of the team who isn't necessarily trained properly or whatever, and they kind of start doing these things and they forget about, they intend to clean it up later, and it lives there for quite a while. Or you acquire a company, and they've got a bunch of passwords or secrets in their code and nobody really took care of it. So trawling through your code base to look for those secrets is a good way to reduce, again, your overhead. One example of an organization I know of, you know, they were doing some dev work for a client. They did the hard-coded secrets. The developer took that code home. It got published into a public repository, and then the secret that was then used to compromise the end client. And so, you know, again, keeping those secrets out of code is really, really important. The last one is my nod towards the resiliency conversation. And this is a tool called Chaos Monkey. I'd be curious if anybody's heard of Chaos Monkey. So one of the challenges with code, especially in a cloud environment, is understanding like what happens if a particular system fails. Is my overall application still going to be resilient, right? So classically, I've got automated orchestration that allows me to like fire up new systems that auto scale and all this kind of stuff. But things can happen in unpredictable ways that cause my overall application to fail for some reason. So Chaos Monkey is actually an open source tool set that was developed by Netflix. And Netflix has this running in their production infrastructure. And what Chaos Monkey does is it goes and it intentionally breaks things all the time, which sounds like a crazy thing to do as somebody who's running an operational system. It's like, it just like kills off systems and breaks connections and all this kind of stuff. But what Chaos Monkey has forced the Netflix team to do is design around that kind of chaos. Design around a data center failing, design around, you know, a control instance failing, and design around an API being unavailable for a period of time. And so that builds a much more resilient application stack to help ensure that the application is continuously running. Although generally speaking, when we talk about code security, people think about integrity and privacy of information. But another big important aspect of security is actually availability, right? And I can launch all sorts of attacks against systems that deny the availability of that system, and that's a security breach as well, right? And classically, a denial of service attack is a version of one of these. Taking a breath. Any questions? All right, I'm not seeing anything. So a couple comments. I mentioned a lot, like third-party testing is a really common thing that's being done. We talked earlier about black, gray, and white testing. Not all pen tests are equal. One of the things that you typically don't see in black, gray, and white testing, but is popular for larger organizations, it is more expensive to do, are social and physical penetration tests, right? So social penetration test looks at the human factor and tries to find ways around not just the code, but also the people who are running the code or administrators or somebody else within the organization. And so classically, in this case, the recent Twitter hack that I mentioned that occurred last week with the Bitcoin wallets and all that kind of stuff was not a software error, although some could argue that there were some design flaws in how Twitter implemented controls around these critical accounts. But it was a social engineering attack that took advantage of, you know, basically bribable people inside who had administrative access to passwords and panels inside of Twitter, and then used that kind of monetary attack angle to compromise these accounts, right? And so, you know, for most of us, we don't necessarily have to worry about social engineering happening all the time, but for high-profile systems, social engineering is a completely valid attack surface. The thing to remember about attackers is that, like if all the rest of us, they're lazy. And so they're going to do whatever's easiest. So if you've done a really, really good job of locking up your code, but your people are soft, then they're going to go after your people. And similarly, physical penetration tests, these are less common these days, partly because most of our stuff is in the cloud and we don't care about the physical stuff anymore. But there's all sorts of physical penetration tests that have been very effective in the past. And the classic is like dropping the USB key in the parking lot, somebody plugs it in, it's infected, and they've got a compromised system. And from a security perspective, the kind of classic success story of that kind of physical attack was the Stuxnet virus that the United States and Israel used to take down Iran's nuclear processing centers, which was an air-gapped network. They managed to get a physical penetration test to compromise that network. And then, of course, everybody else took advantage of the code of Stuxnet once it was out in the wild and became a big problem. Another thing to know about penetration tests is, you know, you can hire all sorts of different independent third parties, and you know, they're all bringing their own expertise to the table, but there traditionally hasn't been a standard of what good looks like for a black, a gray, a white penetration test. This is starting to evolve, and there's an industry group in security called OWASP, the Open Web Application Security something. I can never remember exactly what the acronym is. And they've come out with a standard for code assessment based on the importance of that application. So they've got a standard 1, a standard 2, a standard 3, level 1, level 2, level 3. And based on the sensitivity of the data you store, that kind of stuff, you might want a level 1, level 2, or level 3 assessment against your code. And again, basic level 1 assessment is kind of something that can be done entirely remote pen testing, black-gray testing. Level 2 and level 3 looks at not only kind of that vulnerable surface, but gets into code reviews and security architecture and everything else. And so classically, level 1 is like low criticality applications. Level 2 is anything that stores significant sensitive data. So think about this as like your banking applications or your health tech applications. Level 3 is like anything that's got very sensitive data. So think high value transfer actions like Swift account software, things that like store nuclear codes or launch spaceships. You want to get kind of level 3 assessments done to make sure that they're really, really locked down. All right, so we've done a whole bunch of testing and we've pushed our software out there into the wild. Fantastic, right? Now we're not done, right? Because inevitably we all make mistakes. And so what we need to do is we need to be able to detect bad actors when our software is in the wild. A lot of developers and even testers think like it's in the wild, you know, I might get a bug report, but I'm not really too worried about like what's actually going on when it's out there. And so there's a few things that are really critical. One of them is instrumentation. And so if you think about your application, it's going to be running, you know, doing its thing, you know, logging in users and allowing them to order pizza or whatever it is. And I need to be able to know what's going on and how users are using the system in order to be able to troubleshoot, address problems, and look for security risks, right? So this means I need to have good logging in place, right? So for example, if I don't log when somebody, I don't put a log entry into my system when somebody logs into my application, then I don't know, for example, that you know somebody is trying 10,000 times with different usernames and passwords. I don't have any visibility to that, right? So logging is a really critical phase of your application design to make sure that at the back end, you've got kind of the necessary visibility to do your job. And I'll give you a specific client example that I have. I have a support team where they basically are required to kind of keep customer credentials to remotely access their client systems in order to be able to troubleshoot client software problems. But the real reason that they need to do this is because they don't have the log data to troubleshoot these problems remotely. And so as a result, they have to kind of access the system and try to replicate the problem and all this kind of stuff. And so that's created a security risk because they have all these credentials to these client systems that store sensitive data, right? And so that's a design thing around making sure I'm logging well so that not only the security team, but also support can do their jobs without having to kind of find workarounds and break it. So once I've got logging in place, then I need to have some sort of alert and triage process in place, right? So hopefully my logs have given me enough information so that I can identify and then respond to malicious activity. So if somebody is, brute force attacking my login page for my, financial transfer service, and they get in, right? And so now they've got in, and I need to know that, right? So I need to have some sort of monitoring service or system that alerts me when something has happened, so that my security team can go, oh, this account was seeing a brute force attack, it got compromised, they logged in, I'm gonna cut off that account, I'm gonna block it so that they can't steal a bunch of money or that kind of thing, right? So that ability to alert and triage based on the data that is being instrumented and logged is another critical aspect of code security and how I kind of design my application. And then lastly, like once I've done this instrumentation, alerts, and triage, I need to have a feedback mechanism so that I have the ability to go, hey, I learned something new about what my attackers are doing, and I'm going to impact that in my design, right? So going back to the brute force password attempt story, maybe I need to put a threshold timer in there so they can't try 100,000 login usernames and passwords in 5 minutes, right? So now I go back and I make an update to my code that says, if a single IP address tries to do more than 100 logins in 5 minutes, I'm going to time out that IP address for the next 2 hours. So I'm going to slow down the attacker to make them less likely to be successful. So that feedback mechanism of, I've got some good instrumentation, I can see what's going on. Now I'm going to make some design choices in my application to improve the security the next time around so that attacker can be less successful. This is an important full loop aspect as it relates to security. And so what that gives us is it gives us kind of this agile feedback loop, right? I design my product, I code and test my product during the design, after the design phase. I release it, it's in the wild, it's kind of constant iteration DevOps cycle. I'm doing monitoring and access, and then I'm getting opportunities to improve the design and close the loop. And that cycle of not just releasing code and forgetting about it for a year is really, really critical to reducing your overall risk and footprint. breathe. All right. So let's look at this breach from what we've just learned, right? So a few things that really kind of stand out to me when I look at this particular story is the story of it was only 61 million out of 137 million user accounts that were compromised. And again, that was a design choice as it relates to using social logins rather than having to create usernames and logins for every single user. So that helped reduce their risk overall, right? The choice of using bcrypt rather than just using some generic password hashing algorithm dramatically increased the amount of effort that the attacker had to go through once they compromised the password database, right? So that again reduced their risk. So that's again a design choice. Now, I mentioned earlier that 4 million accounts were later decrypted, and everybody's like, well, how did they decrypt that? Well, one of the things that attackers have is they have like common password data sets, right? And so they can try these common password data sets against these big password databases, and they can try password 123 and let me in and lock out and all this kind of stuff until they have a successful login. They successfully decrypt based on the salting and hashing. And so then they know your username and your email address and your password. The next thing the attackers would do is they take that dump and they go, all right, so Michael used, Michael at cobalt.io, and he used let me in as his password on Canva. I bet you he's used let me in on his password in 5 or 10 other sites. And so they go around the internet doing this password stuffing attack to see where else I might have used that same username and password. And classically, e-commerce sites are constantly hit with these type of attacks where there's a big database dump somewhere, and then the e-commerce sites get barraged by people trying to see if shoppers on their sites have reused passwords as a way to then go and do some free shopping on Michael's dime. And so password reuse for the users is important, but also kind of how you manage that internally is important as well. And so this kind of response action of quickly resetting the OAuth tokens so that even if the passwords had been changed, you cut off the attackers is another really important effect. So the good story about this whole thing is, as bad as the hack was, the fact that they were compromised, Canva determined it themselves. They detected the attack internally. They had some visibility. They took a variety of actions, right? And then they did a closed loop and they improved their security as an outcome. And so there's a lot to learn from these lessons and what you can be doing to reduce your risk and to deal with security well. So I'm kind of at the wrap up stage. So hopefully, if you have any questions, you can kind of bring them to the chat and stuff like that. I'm going to actually minimize my slides so I can see the chat a little bit better. So a little bit about how Cobalt helps with all this stuff. This is kind of my tale to Shobit's talk with Optimus. So we help basically secure your code, secure your business. So everything from security architecture, the design specification phase, through to training for your developers, testing. We do the black, gray, white, ASVS level penetration testing, that kind of stuff. We help organizations with a variety of tools. So this is security infrastructure, helping you, implement vulnerability scanners, WAFs, IDS, IPS, those sorts of things. And then, that day 2 operational monitoring of, keeping eyes on, like, is somebody trying to compromise your AWS or your Azure environment? Are they brute force attacking your username and login page? So we do that logging, we do alerting, we do triage, and we give your teams feedback on how they can be improving their application stack. So I'm going to take a breath here and say, if you have any questions about any of that stuff, you can contact us at info@cobalt.io. And if you email me and you'd like the slides, I'm happy to provide them, or if you're interested in future events that we're doing, or just need support in general. So.
I think we might actually have a question here from Shri. It looks like you have raised your hand. So I'm just going to unmute you here.
Great.
So you can...
Hello, can you hear
Yeah,
me?
go ahead. Yeah.
So I really like the presentation. I just had a question about the cycle that you explained in the post-release slide.
Yeah.
So you talk about how even after releasing a product, it's good to monitor the activity and go back and improve the design. So for,
yes,
let's say, an application that's live and you're updating it, And when you're improving the design of the code, would you suggest it's also good to improve the testing methods? Like if I'm using BlackBox, but I want to switch to WhiteBox based on the code structure that I have now, would you suggest that's a good change?
Yeah, so I think generally speaking, so think of BlackBox, GrayBox, WhiteBox as what you might hire an external party to do to test and validate that you've done good code security. So you hire a third party, so you get a report that you can provide your customers. But you could apply all the principles of Black, Gray, and WhiteBox testing yourself within your own team, right? And so I mentioned, for example, in WhiteBox testing, you do a lot of code analysis, SAS and DSS testing. And so a classic improvement to your point would be to incorporate SAS and DSS testing into your CI/CD pipelines so you discover those vulnerabilities rather than somebody else discovering them. So yes, absolutely. You should be looking over time, as your business grows, as you have capabilities and bandwidth, to incorporate those kind of testing methodologies into your stuff. And there's the nice thing about these tools is you don't have to imagine all the test cases yourself, right? Because, as in QA and test, you're constantly like, what are my UI, UX test cases and all this kind of stuff? And so all these kind of security test cases are built into a lot of these tools to help make your job easier. Did that answer your question?
Yeah, thank you so much.
Great question. Thank you so much. Does anybody else have any other questions?
Someone said thank you from Victor, but I actually have a question because I think that obviously cloud is super important these days, especially with COVID-19. Everyone's moving to the cloud and moving quickly. What would you say are kind of like 3 low-hanging fruit in terms of security that you see people, often, overlooking that they can easily implement, that they can see really great results from?
Yeah. So there's 2 or 3 things that immediately jump top to mind. The first area where most people make mistakes in the cloud is with identity and access management. So this is how they manage credential and authentication between different services in the cloud and how things interoperate. And so it doesn't matter if you're using Azure or you're using AWS or you're using GCP, all these have got identity and access management platforms. And classically what we do is we might be testing, we might be running problems, making things interoperate. And so we open things up more than we should during test, and we forget to lock them back down during prod, right? And so this is classically one of the things you hear about a lot in the press is like, business deployed an S3 bucket on AWS and it was made public and somebody came in and slurped all of the data out of that and then they had a data breach, right? And it wasn't that the bucket was designed with like, this is intended to be public information. What happened was somebody in test or in kind of the development phase was having trouble making it work. And then they opened up the permissions on the bucket to make it work during the development phase. And they forgot to close it back down. So those sorts of IAM problems are a really big one. A second one is the cloud providers are actually getting really, really good at providing all these sorts of pre-check security advisory things built in, right? So I'm not as familiar of what it is on Azure, but on Amazon, for example, there's something called Trust Center. And there's like other ones called Security Advisor and stuff like this, where the cloud platforms will actually look at how you've deployed your cloud infrastructure and say, hey, you're not necessarily following best practices and guidelines, and they'll give you advice on specific steps that you can take to lock things down. And we actually ingest that as part of our security monitoring service to say and provide feedback to the client saying, there's 12 pieces of advice that they've given to you, but here's one that's really, really important based on the traffic that we're seeing in your environment. So those are 2. The third one is, and I think this is particularly important for our test community, is that people often don't remember to think about the fact that their infrastructure is now code, right? And so in the past, a lot of organizations that are kind of early in their cloud adoption, they do a lift and shift. So they're running something in DigitalOcean or in their own data center, and they kind of take these virtual machine instances and they move them to the cloud and they run as virtual machines on EC2 and stuff like that. But the kind of modern cloud stack is dynamic, orchestrated, auto-scaling services and all this kind of stuff. But fundamentally, the way these instances and these Lambda services and these kind of spot services are deployed is through code, right? And that code is actually subject to vulnerabilities in the same way that the code that runs your application is. And so if I don't actually have a good QA CI/CD pipeline around my orchestration code, then I could make just as many errors in terms of how I deploy. So an example would be, I've got code and it deploys a new instance to auto scale my front end web service. And, I've done something wrong in that code, and that opens up a permissions error that allows that service to be compromised, right? So those are the sorts of things that need to be kind of considered in your test cases. It's not just the application itself that's running, but it's the code that actually deploys the infrastructure. So those would be three things that kind of jump top of mind. Thank you.
Thanks. Are there any other questions from anyone else?
Okay. Well, as I said before, please feel free to contact us at info@cobalt.io. I'd love to follow up and answer any questions that maybe you didn't feel were great in front of an audience to ask, but we're here to help. And also, if you do want the slides, email me there, and I've got a glossary and definition at the back and all that kind of stuff I didn't get into. So, that you don't have to kind of, what did Michael say about this, right? So thanks so much for giving up a chunk of your Thursday night. Hopefully you learned something and it's helpful, and we're just here to help make the world a more secure place and help you keep your code secure. So I hope you all have a great evening.
Great. Thank you so much, Michael.
Thanks, Michael.
Thanks, everyone.
So before we wrap up, I just quickly wanted to talk about our upcoming webinar. Firstly, I'd like to thank Michael for the great presentation. It was really informative, and I learned a thing or two about it from that presentation. So for our upcoming webinar, we'll have that on August 27th, and we have Neha from Cymax Group who will be presenting. So if you guys want to learn more about what it'll be on, then you can check out our meetup page, and we'll have more details on that very soon. So you can RSVP there. And yeah, that pretty much brings us to the end of our VanQ webinar for today.
Okay, perfect. Well, I hope everyone has a wonderful long weekend, and we will see you next month.
Thanks, everyone. Have a good evening.
Thank you.
Have a great
See you
night.
guys. All the best.
Bye.